10.2, we're going to be writing the equations, so getting that standard form from some different information. So sometimes you're given the center and radius, and you just plug it in. Sometimes you're given the graph, and sometimes you're going to be given other weird things, and I'll talk about some of those that come up in the homework. So if you have a graph, get the center and the radius. Everything else, you're going to be using Pythagorean theorem at some point if you have that other information. And then it's just plugging in the formula once you have that. So the first example, center, -11, -16, radius 1. So remember the standard form is x minus h, so you change that sign. Y minus k, so you change that sign. And you square the 1. And that's it. So when you're given the center and radius, it's super easy. We're going to try it from a graph as well. So look at number 2. So this graph, you want to figure out, okay, what is the center and what is the radius? So go ahead and try that and then write that down. So your center here is on a halfway point, so just estimate. This one is at about 4, then negative, so it's past -3, so it's about -3.5. And then the radius, we just want to count from the center. So from here we go 1, 2, 3, so the radius is 3. So in our standard form, we have x minus 4 squared plus y plus 3.5 squared. And then remember to square the number on the right side. That's it. If it's given to you as fractions, put your answer as fractions. If it's given to you as radicals, put your answer as radicals. If it's given to you as decimals, answer as decimals. So just be wise with that. Most of the graphs, I think, are whole numbers anyways on the homework. It's not too bad. I do want to go through an example that pops up on the homework that's kind of weird. So we're just going to have a bonus example problem. And that is number 13 on your homework. So you're given that the ends of your diameter are 17, -7, and 11, 3. And it's super helpful to draw this on a graph. So you've got a graph here. We go all the way over to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I wish there was a way to just add a graph in here. So let's see. Yeah, it doesn't look like it. Oh well. Oh shoot. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we've got a point at 17, -7. So it's way down there. And then we have another point at 11, 3. So that's up on top. Let's see. It's about here. And we have a circle that connects those 2 points. Remember, a diameter, okay, there's a center point somewhere in here. And we have to figure out where is that. And to do this, we just kind of halfway it. So from this to this point, to get from that point to that point, this went over 6 and down 10. So to go halfway is over 3. So 11, 12, 13, 14. And then to go down 10, but halfway would be 5. So to go at 3 and down 5, this guy right here is at -2. So it's just halfway between the 2 points is your center. So your center here is at 14, -2. And if you can look at the 2 points, you could also find the halfway without drawing it. It just takes a little bit more thought process. but it's up to you which one you like more. And then we have to get the radius. So the radius is probably the tricky part with Pythagorean theorem. So this triangle right here was up 5, okay, same as there, and over 3, same as that. It's that halfway. And you just have to do Pythagorean theorem to get this, which is r. So 3 squared plus 5 squared equals r squared. And you don't even need to break it down to r because we want r squared in our equation. So you get 9 plus 25 equals r squared, which is 34. So our equation is x minus 14 squared plus y plus 2 squared equals, and then r squared goes right there. So it just takes a little more thought process for those last problems. So make sure you get some of those in. Get lots of practice with those because they're tricky.